So what we're doing, guys, so what we're doing today is working with absolute value functions and graphing them. Now, the absolute value function, this is here the parent, our main f of x equals the absolute value of x. And we'll be referring back to this graph here on more than one occasion. Now, the function f of x is the graph. So the graph of f of x equals the absolute value of x is a v-shaped graph. So when we look at this function here, the absolute value of x, it is a v-shaped graph. When we graph it, it looks like a V. And the domain for this is going to be all real numbers. And the domain for any absolute value function is going to be all real numbers. Now, the range is going to be all the values greater than 0 for this function here. For the general one, for the one, our parent function, what we call the parent function, the range is going to be y is greater than or equal to 0. Because the smallest y value is at 0, it's at the x-axis, and it goes up. So this is for the parent function. Now we're going to have some transformations like we did yesterday where we moved it left to right, up, down, vertical stretch, vertical shrink, which will change the range. It changes the values of the range. And the vertex, the bottom of this V. And that's what we're going to be looking at, is graphing these different absolute value functions. And we're going to be coming back to that main overall function. Now, when we look at this first one here, the first one is f of x equals the absolute value of x plus 3. Now, when we talked about adding something to the outside, that was what? Our vertical or horizontal shift. Or horizontal translation. So horizontal was our left, right, and our vertical was up, down. Now the horizontal or the vertical translation was our f of x plus k, and our horizontal was f x plus h on the inside. It'd be a vertical. We're moving the normal, the absolute value function, up 3. So the one that we have at the beginning, that picture that we have, we're just taking that graph and moving it up 3. We're translating it 3 units up. Now another way we can look at it is with a table, an XY table. And when we look at this table, we're mainly going to look at this here, -2, 1, 0, 1, 2. And we're going to use that as long as it's not moved to the left or right. If we have a left or right translation, a horizontal translation to the left or right, we'll move these numbers to the left or right, whatever that amount is. And we'll look at that here in a minute. But since we said this here is a vertical translation of 3 units up, we're not going to move it anywhere. We're going to use these 5 numbers, -2, -1, 0, 1, and 2. Now to find the y values, what we're going to do is we're going to plug in these numbers. So the first one I'll do is the absolute value of -2 plus 3. I'm plugging in -2 in for x. Right, because the absolute value of -2 is 2, and 2 plus 3 is 5. Then we'll do it again with -1, and we'll have -1, the absolute value of -1 plus 3. Because the absolute value of -1 is 1, and then we have plus 3. And 1 plus 3 would give us 4. Now we'll do the same thing with 0. this would be 3, because the absolute value of 0 is 0, plus 3 gives me 3. So what's the absolute value of 1? If we take the absolute value of 2 plus 3, the absolute value of 2 is 2, plus 3 gives me 5. So again, we're plugging these in one at a time, so make sure, so we're just plugging them in, we're taking the absolute value of it. Here we take the absolute value of negative 2 plus 3, so the absolute value of negative 2 is 2, 2 plus 3 gave us 5. We did the same thing with negative 1, 0, 1, and 2, and we got these points here. Any questions on this here so far? Now what we can do next is we can plot each one of these points. So our first point is at negative 2, 5. So we go over negative 2 on the x and up 5. Our next one is negative 1, 4. So we would go over the negative 1 on the x and up 4. Our next point is 0, 3. So 0 on the x and up 3 on the y. 1, 4. And last one is 2, 5. And then we would draw our V shape. On Big Ideas Math, it's going to have you do 2 rays. It's going to say array. And to do the ray on the Big Idea Math, what you'll do is you'll start at this point here where they come together and pick a point going this direction. And the same thing will work going the other way. We'll pick that point and then draw the ray.
But how do you know that you need where's like the 2, the negative 2, 1, and...
So we're always going to pick 5 numbers. So we're going to stick with negative 2, negative 1, 0, 1, 2 for x, as long as there's not a horizontal translation going left or right. If there is, we're going to move it over that amount. We'll move those 5.
If it's a
Horizontal.
vertical,
We're going to stick with these 5. If it's vertical, we're going to stick with these 5. Unless it's moved to the left or right, we're going to stick with these 5 here. Any questions on this so far? Okay, now we're almost done with this one, because we still need to describe the domain and range. We need to talk about the domain and range. Now the domain for this function here is going to be all real numbers. The domain for this function for any absolute value is going to be all real numbers. The domain is always going to be all real numbers for these absolute value functions. Now the range. So we talk about the range, we're talking about the y values. Now what is the smallest value or biggest value of y? Well, here we're going to have a smallest because the function is going up, yes? So the smallest y value that is given to us is at what? Three. And y is going to be greater than or equal to 3, because when we look at this graph, the smallest value going up and down on the y, up and down, is 3, and it goes up from there. So the smallest y value, or the smallest value for the range, is 3. So when you talk about the range and these inequalities, so for this here, we would say y is greater than or equal to 3. This would be our domain and range. It's the other part of this answer. Questions on this here? So let's look at this one here. Now this here we have the function f of x is equal to the absolute value of x minus 2. It would be a horizontal translation because we have a number inside, yes? So it would be a horizontal translation of 2 units to the what? To the right or to the left?
Right.
It would be to the right. Because it's inside, when we talk about right and left, it's opposite of what we think. So since it's minus, it's moving to the right. So this here is moving it 2 units to the right. It's a horizontal translation. So when we go to graph it, before we picked -2, -1, 0, 1, 2, yes? So what did we do? We moved it 2 units to the right, yes? So I'm going to change this. I'm going to move these 2 units to the right. So I'm going to add 2. So now we would be at 0, 1, 2, 3, and 4. Because we moved all of these here right. So if we have this horizontal, if we're moving, if there's a horizontal translation, either direction, we're going to change our numbers to.
So.
Yes.
What he's saying is we always start with the top numbers
Yep.
for every number, but the number on the question is like the number that we're going to be using to move those original numbers.
Yes. Because really what we want is that v. Because each one of these absolute value functions is a v, yes? What we're really looking for is that vertex, that point, that lowest point of that v. We want to have it in our graph. Now, on the last one, the lowest point was at 0, 3. Yes, that's where the smallest point was. That's the vertex. Now, that's also the same. Well, we got rid of it. For our basic f of x, because the vertex is at 0, where x is 0, yes? Well, if it's at 0, here we said it moved 2 units to the right. Every point is moving 2 units to the right. So is that vertex, that lowest point, going to be at 0 for x anymore? No, it's moved over 2 units to the right. So we're adjusting these points that we're plugging in to figure out the values for by 2 units to the right, because we want that vertex. We want that lowest point to get an idea of what the graph is going to look like. That's why we're moving this here. Now at this point here, we're going to plug these points in for the absolute value of x minus 2. I'm going to erase these here so we can see it. So if I plug in 0 in for this here, we have 0 minus 2. Well, what is 0 minus 2? It would be, and the absolute value of -2 is 2. Okay, our next one is going to be 1. We're going to do 1 minus 2. Well, 1 minus 2 is? Would be -1. And the absolute value of -1 is? 1. Then what number are we going to do next? 2 minus 2 would be? 0. And the absolute value of 0 is? 0. Then we would do 3. 3 minus 2 is? 1. And the absolute value of 1 is 1. And it would be 2. If we can do it with 4, well, 4 minus 2 is 2, and the absolute value of 2 is 2. So it's always going to have this V shape. All of these absolute values are going to have this V shape to them. Give you all a second to write those down. We good with this here? We've got these points written down? Yes? Okay, so now we can come back up here to the graph and plot these. So 0, 2. I would go 0 over on, well, I wouldn't go anywhere on the x. I would just go up 2, because that would be 0, 2. 0 on the x, 2 on the y. Our next one is 1, 1, so we'd go over 1, up 1. Our third point is 2, 0, so I would go over 2 on the x, and we wouldn't go anywhere for the y. Then our next one is 3, 1, and 4, 2. So these here would be our 5 points, and it kind of gives us an idea. It gives us that V shape, yes? Next. So the next thing we need to do is we need to draw the line for it. So if this were on Big Idea Math, what we would do is we would click the ray item, and then select the point down here at the bottom, because this is the bottom, it's the vertex, yes? And then you would select one of these points, one of these 2 points here, and it would draw your line. Then we would select the ray again, reselect this point, and pick one of the points going the other direction, because that would give us our 2 sides. Any questions on this here? That brings us to the last part, the domain and range. What is the domain for this function going to be? All real numbers. The domain is always going to be all real numbers. Now looking at the y values on the y-axis, looking at the values on the y-axis, is the graph going up or down? Up, yes? So all the values of y are going to be greater than or equal to, because if it's opening up, if it's going up, the range is going to be y is greater than or equal to a number. Now we just need to find the y value of the vertex, the smallest y value that's given to us. 0. Because this point here, 2, 0, that is the smallest y value. And the y value for that point is 0. So the range is going to be y is greater than or equal to 0. And that's it. Any questions on this here? You good with this here so far? Okay.